Okay, so for this AL buffer problem, it's telling us that it contains 0.32 of this NaH2PO4 and 0.222 of the Na2HPO4. If we have 0.3000 moles of this potassium hydroxide and it's added to 150 milliliters of this buffer, what is the pH of this solution? So I went ahead and wrote out the equilibrium for this buffer, and then also found the concentration, so I don't have to do that. And then I also looked up this Ka2 on the reference table, which will come in handy in a little bit. So then I'm going to just go ahead and create an ice table for this equilibrium up here. So we know from the problem we have 0.382. We don't consider water. And then 0.222 of that solution. So then since we have to add this base, we're going to go ahead and do that. So subtract 2 and add 0.2. So then that's going to go ahead and give us, this is going to equal 0.182, still 0, and then this is going to equal 0.422. So now those are our new initial calculations after we added the base. So our initial point. So then we're going to change it. So that's minus x, no water. This is just going to be plus x, and this is going to be plus x. So we have 0.182 minus x, and 0.422 plus x. So then we can go ahead and write out our Ka equation. So Ka equals, and then I already found that Ka2 for this, which is what we're using. So it's going to be 6.2 times 10 to the negative 8. And then we can go ahead and write this out. It's going to be over reactants, which is and then that is, then we just use what we found in the ice table. So that's x plus x, and then on the bottom 0.182 minus x. Okay, and then since the concentration of that is smaller or greater than 100 times the original Ka, then we can just get rid of this and this. So then that leaves us with 6.20 times 10 to the negative 8 equals x times 0.422 over 0.182. And then since we want to solve for x, we're going to have to go ahead and rearrange this equation. So we're going to multiply and then divide. So we have 6.20 times 10 to the negative 8 multiplied by that 182, and then divided by 0.422, and that is going to give us x. So I already went ahead and found that calculation, and that is x equals 2.67 times 10 to the negative 8. And then since we want to find the pH of that, we're going to have to log it. So negative log of, what was it? 2.67 times 10 to the negative 8. And then that pH gives us 7.573. And this is the answer.